sorry to interrupt, but I just got a message from one of my friends. This meeting isn't being live streamed, it seems. Is that so? Because even I am not be able to see it on YouTube, sir.
Oh, Victoria?
Uh,
Yes, sir.
I mean, is it supposed to be live streamed?
Yeah, it is live streamed only, Professor.
Yes, sir. It is coming now on YouTube. Thank you so much.
Yeah. Okay, thank you. Okay. Yeah, so basically the point is the power supply noise. Okay, so whatever initial hypothesis we had was all wrong. There was no problem because of the battery or whether you connect your laptop to the power supply, nothing. The noise is very much in controllable limits. Okay, in fact, a digital IC is supposed to work with such noise. That's the whole point of digital compute. Okay, it is supposed to work with that kind of noise. So therefore, the power supply is not the issue. So what we found was if I use the power supply from the kit, ADALM kit, and then use the signal generator, external signal generator, instead of channel A, right? Everything worked perfectly. So clearly it indicated that this something was not, it was not able to drive it properly, and therefore this was happening. So then I asked Aditya to try it out with this, independently. I think Aditya's father also had come up with the same hypothesis. So thanks to him, he bought one of these ICs, which does a CMOS to TTL interfacing, and he was able to show that by putting that chip in the signal path between channel A and your counter, the problem went away. Okay, the counter worked perfectly after that. Okay.
yes, Professor.
So this is the net. So when you come here, we will give you one of these ICs. Okay, this CMOS to TTL compatible. You can see it for yourself.
Yeah.
So that is one of the ICs that I have to add for the next batch. Victoria, can you make note? And Aditya, can you please send that IC detail here?
Yes, sir. Should I send it in the chat?
Yeah, send it in the chat now. So that Victoria make note of this.
So 1 second.
Professor, in the meanwhile,
Yeah.
what is duty cycle?
Duty cycle is actually, in my lectures, I had mentioned it, no? It is the ratio of the on period to the total period.
Okay, but we want a continuous signal rate in that.
No. What do you mean by continuous signal?
If you want a clock signal, that means that the clock signal must be continuous.
Correct.
Then,
Yeah, but that's why you see in Aditya's code, no? What has he done? He has simply done while true.
yeah.
That means that Python code will keep running.
Mm-hmm.
So it will keep generating the clock. That's all.
That means that duty cycle was 100.
Duty cycle is 100. So what has he done? Red LED. So there are, see, what he has done is there are 4 of these. Okay. Pin dot red LED, green LED, blue LED, right? 0.1, 0.1, 0.1, 0.1, 0.1.
Professor, I've pasted the details of the chip in the chat box. Can you please take a look at it? It is the CD40106B.
Okay, yeah, that's it. So, Victoria, just make note of this. 1 second.
Noted, Professor.
Yeah, okay, very good.
Yes, sir. This is the chip. So, just a note that there may be many other chips also which may have the same functionalities, around 14 chips. So, I can also try doing the same experiment with that also. There are, I think,
No,
around
that's
14
okay.
chips.
That's okay. I think if it works with one, it's fine. Okay. So, yeah, so Aditya, how are you controlling? Where is the address for this side? This is what I'm not able to understand.
Uh,
Professor, address as in the of the
You
chip.
know, for the four IO pins, I
he
thought
had
you
used
had
one external library, sir.
no, that's okay, but you must be addressing, okay. You're calling it PIO 0123.
Yes, sir. Yes, sir.
Okay. Got it. So you're doing,
Yes, sir. It's actually an abstraction library which
ah,
wraps around SMU.
okay.
Yes, sir.
Oh, and you have called it AR IITM.
Yes, sir. AR IITM is AR underscore IITM is my own version of that.
Okay, where is that file?
In the GitHub
On
itself.
GitHub, sir. It's
Wait.
on GitHub.
That's what I need to see.
Uh,
No,
Aditya,
Sir, it's a WHL file. You'll find it in the WHL folder, sir.
yeah, got it. Uh,
I've also pasted the link in the chat for which will directly take you to the WHL for on my GitHub.
Oh, okay. So these they don't have access to that WHL file, is it? The source.
It's there, sir.
Where is it? I only see a WHL file. Where is the source file?
Sir, it's in the WHL file itself, and the main reason for this is that I didn't want the students to upload, maybe wrong hex codes and brick their device, lose the functionality of their device. So
Yeah.
I didn't
No,
want the students to do that.
no. I understand that. So ideally, we should tell them this is what it is, but here is the code for you to also understand what's happening inside. That's all. Okay.
Yes, sir. Okay, yeah. For that, they can open this WHL file using WinZip, and they can take a look at all the codes which is in there, the Python.
Okay. I have to unzip, is it? Is it? Okay, that's what I didn't know.
Yes, sir. If on a Windows device, if you use a WinZip, it will be a lot easier.
Okay, I unzipped it. Yes, I think now I got it.
Yes, sir. And on Linux, for the ones which I use, if you simply click it, then it opens up everything for Linux.
Yeah, got it. Okay, I'm able to now see it.
Yes, sir.
Okay, very good. See, now I see this. Okay.
Right, sir. This I actually took this precaution, as I said earlier, to prevent the students from bricking the device or spoiling it further.
Okay, so basically, your address is what? This 28, 29, 47, and 3, is it?
Yes, sir. They are the abstractions, the pin numbers. So these 27, 28 represent the
Yeah.
pins on the board.
Okay. Okay, got it.
Yes, sir. It is also very highly undocumented. I mean, even if you go to the EDLM site, almost nowhere is it mentioned that this pin number corresponds to this pin on the physical board, and also it is
Yeah.
very rare to find somewhere.
No, this is excellent. This is top class. Okay, very good. So I
Yeah,
think,
sir. I got it using trial and error, so that
yeah,
was a really long way which I did.
yeah, sure. Okay, done. Okay.
Yes, sir.
So I think what I will just do now. Okay, sorry. So right now you are now in a position to finish this 7 segment display, right?
Yes, Professor.
Okay. Now key thing, you have received only one 7 segment driver. Okay, so you cannot drive 2 displays.
yes, Professor.
Yes, sir.
Okay, so connect only one driver. See, the LSB is what matters. That is what is going from 0 to 9. The other thing just goes to 1. Correct? The other digit either shows 0 or 1.
Yes, Professor.
Okay.
So I was thinking of maybe we could hot swap the chip, so I can wire it according to the two 7 segment displays, and whenever I want to see one of the displays, I can just remove the chip from the other display and connect it to the first display,
No,
and
no, 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 no,
so
no.
on and
Don't
so
do
forth.
that. Don't do that. You just hardwire it so that you're driving the LSB. Okay. I will, when you
Okay,
come here for your evaluation, I will tell you what to do for the MSB.
okay, sir, definitely.
Okay. So just the final digital experiment is only driving the LSB of the display. That's all. So I want you to show me that it goes 0 to 9, back 0, 1, 2, 3, 4, 5. Okay, it should just count 0
Yes,
to
sir.
9, then back 0 to 5, whatever, right? That it should count.
Yes, sir.
Okay.
Uh,
Yeah.
for the backward counting part, we have to just pass everything to an inverter. Is that so, sir?
Backward counting, what I will do is you can, yeah, I mean, it's the same thing, right? Just convert it. I don't know if I was assuming the chip does not do backward counting.
No, sir. There is no separate functionality in the chip.
Okay, then forget that. I'm not interested in that. No,
Okay.
no, forget it because I'm not interested in doing backward counting. Forget it.
Yeah.
Okay. Yeah. So,
Yes,
Victoria, so I will send an email about this, okay, about what needs to be done for the
Okay.
last 2 digital experiments. So, this week and next week, let them just focus on that.
Okay, Professor.
Okay. Actually, what I would say is the counter and then up to the output of the full adder, right, is what I want them to verify. Okay.
Okay, okay,
Then
Professor.
let them finish the analog experiment.
Mm.
Okay. And then finish the display of the digital experiment.
Okay, Professor.
Because after the digital experiment, they need to come here for evaluation and they need to keep the board as it is.
Okay.
Okay. So
Okay.
anyway, you set up a live session on Thursday,
Okay, Professor.
right?
Yeah.
And
Okay.
I'll also probably record a video,
Mm.
okay, explaining the whole thing to them now.
Okay, Professor.
And then I will when I come back to today, right, I'll record a video
Mm.
so that I explain to them exactly what the problem was, what was happening, and what needs to be done going
Okay.
forward. Okay.
Okay, Professor.
Chalo. Right. Okay
So,
then. See you all. Yeah.
Professor.
Professor, excuse me. In the meantime, if Victoria ma'am shares the details of the GitHub and all of the things which I've compiled into the exe file over email, I've actually shared it with her also. So if
Yeah.
it is shared with all the students, then maybe they will get an idea about GitHub and how the things work. Because
Yeah.
so far I've been contacted by multiple people on a direct messaging basis. To get it set up for them. So, but still they don't have an idea. So, I mean, if an official mail is sent out with this link and the details which I have compiled, it will be easy
Yeah.
for all the students.
So can you do one thing, Aditya? Can you draft that email of how to access GitHub, what to start with, how to download, how to read, right?
Yes, sir, definitely.
Right? Yeah. Or I would say the best thing, I find the best thing to do in such cases is to make a video. Just do a screen grab while you do the whole thing.
Yes, sir. I'll do it today. And sir, in the email which is shared with the students, if this link is included, it will be easy because just like we have in Linux, a README file is included, which basically has all the details. And yeah,
No. I know,
although
but
I will also be,
yeah,
I will also be making a video.
exactly what I'm saying is you actually make a video, okay, of this whole Python download, install, control, everything, okay? And
Yes, sir, definitely.
in the email, right, you again draft the email so that people who want to, do it directly without seeing the video also can do it. Saying this you download from GitHub you do read the README, install it according to that. Otherwise, you can see this video.
Yes, sir, definitely. I'll also paste this GitHub link in that.
Okay,
So
that will
in the
be
mail also
perfect.
it will be easy for the
Yeah.
people,
So
as you said,
just
who don't want to watch. Yeah.
exactly. So share that video and don't upload on YouTube. Okay. We will upload it on our channel here. Just share it on G Drive.
Yes,
The video.
definitely. I'll share the raw video with you so that
Yeah. So that this thing. So the video, I mean, what I want to see is how to control and get 4 clocks.
Yes, sir. I'll also include that in the video
Okay.
using 4 P pins.
Yeah. Okay. Right. Fine. Okay.
Yes, sir.
Prof-
That's all. Thank you so much.
Chalo. So yeah.
Professor, one small note.
Yes.
So now, right
Thank you.
now,
Sorry.
yeah, right now we have to focus upon analog experiment.
No. You finish the digital experiment
Uh,
to
the
experiment 3, where I mean digital experiment 3. That is, you are supposed to finish the comparator and the adder part. Correct?
Yeah.
Up to that part, I want you to complete in digital.
Okay, the driver part we have to do on the
Yes.
last week, week 8.
Last week, because that breadboard you have to bring here for evaluation.
Yeah.
I don't want you to dismantle that circuit.
Yeah.
Okay.
Yes.
Okay.
Yes,
So
okay.
Yeah.
okay. Yeah.
Thank you so much, Professor Jamkraman, and thank you so much, Victoria ma'am, also.
Yeah,
I'll
thank you both.
send everything. I'll send everything by today. Thank you so much.
Yeah. Thank you. Okay. So Victoria, live session on Thursday. Okay.
Sure, Professor.
At 4 p.m.
Okay, Professor.
Thank you, sir.
Okay. Thank you.
Yeah.
Bye.
Thank you, sir. Have a nice day.